Hi, everyone. Welcome here. All right, so I'm honored to introduce for this next talk here, we have Grace Kai from Shell, who I've had the pleasure of working with on webinars before. You're all in for a treat. She's going to be presenting on generating synthetic metadata using AI agents and FME.
Cool. Thank you. All right, so show of hand, who is here excited about metadata?
Oh, yeah.
Oh, more than expected. Good for you. And who's here for AI? Okay, yeah, maybe a little bit of both. All right, you're in the right room. I'm super excited to give this talk. So before I can jump in, I gotta show you this slide that our lawyers worked really hard on. Basically, the TLDR is please do not buy or sell Shell stock based on what I'm going to present today. I don't think there's any risk of that, so I'm going to move forward. My name is Grace Kai. I'm currently an innovation lead at Shell. But before that, I was a geometician for about 10 years. And some of my happiest working hours were spent in FME. And so I'm really happy to be able to present here today. The agenda is pretty straightforward. We're over here in the intro right now, and then I'm going to talk briefly about the motivation of the project, so take you through some of the iterations that we did building the AI agents, and then some observations and learnings. All right, so we all, as demonstrated earlier, we all love metadata, and we all know it's important, yet this is probably how it feels like to be a data manager and having to keep up with maintaining high quality metadata. It's tedious to do, and just when you think you're done, a new batch of data would have been uploaded to your platform. But in the age of AI agents, do we even still need metadata, right? Is that just something that we need as, humans to understand our world? It seems like AI agents can do everything under the sun, so maybe this is a relic of the past. Well, the short answer to that question is no, we still do very much need metadata, even in the age of AI. In fact, from experience of deploying AI agents, we have realized and learned that you need more high-quality metadata, not less, because metadata is a very important component in your organization's semantics layer, which is the key for AI agents to understand the organization that you exist in and what the tools are and the data that it has access to. But maybe we can just brute force it during runtime, right? Context window was mentioned yesterday during the plenary, right? They're ever increasing, but as of now, there's still a finite resource. And even if it is infinite resource, an infinite context window for these large language models, it's not the most efficient way of using that resource, and it can get pretty expensive putting all of your data through the LLM at runtime. So it really becomes an optimization problem. And maybe another thing that we can think about is that we're still around, right? Humans interact with, it's still the primary point of contact of these data sources. It's incredibly valuable to have in your organization just to start with. So let's use AI to automate the boring stuff. Okay, so what am I talking about when I say automate synthetic metadata? In the context of this project, we're looking at ArcGIS Online feature services. So this is an example of very bad metadata, or lack thereof, for that matter. Whether we like it or not, this is sometimes the reality of our kind of content landscape, right? You rush through a project, you generate a bunch of content, and then you have to move on to the next project. So a lot of feature services and maps are left with very slim pickings for metadata, and that's not good for corporate memory down the road. So we're really trying to fill out this page, right? The summary, description, tags, categories, and trying to get that metadata health bar over the 75% mark. And so another part of the motivation is that we know it's possible. So this is a screenshot from Databricks, actually. They rolled out this feature over a year ago. And so you can see that this is, there's an AI-generated description for this geochemistry data set. It's not perfect. There's some health risk warnings there that's not very relevant. But what I really do appreciate is that they also generated comments for each of the fields. And through building AI agents that interact with structured data, this makes a world of difference. Okay, so let's talk about some of the iterations. This is the prototype we built. So just for the specs up top, we are using FME 2023.2 with the Azure OpenAI connector and GPT-4o for all of the iterations that you're going to see today. This is a pretty simple workflow, so I'm just going to walk through it. First, we use the ArcGIS Online connector to fetch the AGO items, so feature services in this case. We use the feature reader to sample some of the data, so top 100 rows. And I'm not great with lists, so yeah, exploding lists out. And basically at the end of these formers, you get a couple of columns, which is attribute name, sampled values, and then the item ID from where that data is sourced. AGO item ID, I should say. All right, then we make our first LLM call. So we try to replicate what the Databricks example I just showed was doing. Each attribute with its sample value and the item information is fed into this agent, and a one-sentence field description is generated. And then, so Esri on AGO also have this field value type, a categorization of value. Is the column a zip address? Is it a coordinate? Is it like a Boolean field? So I took that opportunity to really test out a hunch I had, which is that LLMs are really good at sorting unstructured data. And spoiler alert, it was very good at picking out the categorization. And then we use the aggregator to combine all of the fields, attributes back into its item and ask GPT-4o to generate a table description. So here's the prompt that was used. The persona that we asked GPT-4o to inhabit is a helpful technical writer, and then we kind of throw in some system level metadata in there to give it context. This wasn't perfect, but it was good enough for us to continue the journey. So for iteration number 2, we really just threw everything at the wall. I'm not going to go through this play by play, but I do want to show you the prompt that we used. So I was showing earlier, what we're trying to get out of here is the item description, a summary, some tags, some categories. And this is when we really leverage structured output. So we asked GPT to generate a JSON object at the end of it. Yeah. Oh, and I should say that in the description, there are 3 key things that we're looking for, which is where, what, and who. So where does this data cover? What region, right? What is it? Is it a well? Is it a pipeline? And who created it, right? Is it a vendor or a government body, or is it a shell data set? So those are the kind of 3 things that we really look for in good metadata. All right. Iteration 3 is pretty much where we landed. So as you can see, we deactivated the column generation. And that's because it takes time to validate the output. And we didn't want to overwhelm our QC folks by giving them like hundreds of column descriptions as well as table descriptions. So that's parked for now. One very important thing we added is get the feature count from the layers. And then we broke the LLM agent into 2 steps. So thought generation and then editor. And in the editor, we also added a big list of shell-specific acronyms for it to reference. And then, yeah, we use the JSON extractor to parse the results. Cool. So let's take a closer look at the table description thought prompt at the first step. So instead of a technical writer, now we're asking GPT-4o to be a data detective. So let's be honest, that's what we all are when we're handed a spreadsheet with no additional context, right? We have to go digging and sleuthing around. And so its mission is to find the intent of the data package and approach it with a healthy dose of skepticism, because LLMs are too confident for their own good. And we draw special focus on data filters and expressions. So we all know a definition query in a layer can drastically alter the use of that data set. So we put special attention to that. And then, pay attention to feature counts. And look at the extend coordinates. As you can see on the side there, we do provide lat long extents to kind of identify the region where the data is sitting. And then, say you're unsure if the evidence is not clear. This is vital, by the way. I'll talk more about that later. And this is the prompt we used for the editing step. So we parse out the various components that we're looking for, and then we give it a format for the JSON object that we're looking for. It's pretty straightforward. And then the acronyms lookup is just a giant list of acronyms. Okay, so observations and learnings. First, have a bias towards action. So it will rather hallucinate rather than say, I don't know. So give it permission to not know things, right? This one sentence in our system prompt virtually brought hallucination to zero, beyond just this use case, like in the other AI agent use cases as well. So say you're unsure if the evidence is not clear, you're re-diverting the energy, the momentum into something constructive. Yeah. So schema-only analysis led to overconfidence, right? So a lot of our data is kind of variations on a theme, let's say, and they're corporate data sources that have large schemas and on the face of it look very comprehensive, but maybe it's been like filtered down to just like 2 polygons. But the AI, without peering into the data or like getting a full view of the table, doesn't know that and would still say it's a very comprehensive data set, which is wrong. So that's why the feature count provides very valuable context and is relatively cheap to extract as well. So you're not like feeding the entire table into GPT-4o to get that. So we definitely ran into some issues with colloquial phrasing and awkward phrasing. So internally, we refer to gas stations as retail stations, for example. So this is just, an example of that. And then I love this one, right? So instead of saying globally, it would say spanning a broad geographic area covering regions from the Western to Eastern hemispheres. Lovely. So, and as expected, it would not know any shell acronyms. So Stuart here, I already asked Stuart this question. So we'll love to be able to set up an MCP tool for RAG at some point and then just point to that straight from FME. Context filtering and formatted outputs are very important. So I think this has already been mentioned a couple of times. But formatting, FME is great at working with JSON objects, right? So that's a freebie that we by being FME users. So that's great. But as you can see from the second iteration, right, we threw everything at the wall, but it really led to suboptimal results trying to do too much in one step. So context window pollution is a real thing. So that's the dial as kind of AI engineers or AI agent engineers that we're really playing with in this new paradigm, right? So more isn't always better. Another learning we have is LLMs are pretty good with GS84 coordinates. Here's a test we ran. I'm just putting through a bunch of country outlines through 3 various system prompts. The top 2 are extent coordinates only, and then the bottom one is the full WKT, like the full polygon coordinate. It does perform better. This is not passing any geography tests by any means, but even when it's wrong, it's picking like a neighboring country. So depending on your use case, you may not have to rely on tool call to just pick out the rough region you're in the world. So but for more precise workflows, definitely recommend tool call rather than just relying on the model itself. All right, and this has sort of become like a tagline I use internally at Shell, which is, if no evals, then just vibes. I think when we build out AI agents, the intuition is like, oh, it's supposed to do things that I'm not very good at, or it's difficult for a human to do. So we don't really think about cultivating a solid set of evals before we embark on these projects of building out AI agents. And it's kind of like an afterthought. We did think about it. To our credit, we thought about it before starting, but it turned out that we didn't think hard enough, because we thought, okay, look, we have actual feature services that have very good metadata, so we'll just use that as benchmark and see if GPT can meet that standard, right? But we didn't really think about that the good metadata was generated by people that had way more context of the data. So it often included information that you would not be able to find in the data tables. So it's not an apples to apples comparison. So in the end, we still had to default back to crowdsourcing evaluations. So we ran the script on a bunch of content and then gave the results back to the content owners and had them kind of grade the results. So once we have that, right, the next step would just be, if we want to continue to improve upon this, once we cultivate a good set of evals, we can easily use LLM as judge to iterate on it. And okay, so what are the conclusions? Okay, so I didn't really define agents up front and on purpose because there's such a nebulous, fuzzy definition of AI agents. I really like the definition Anthropic gave in their blog post here. So they define agentic systems as a spectrum from more deterministic workflows to more roaming autonomous agents, right? So I guess what I showed today is more on the workflows side, and that's definitely an area FME is very strong in. And I would say that a lot of business use cases, if not most business use cases, really value predictability and explainability. So deterministic workflows are still very vital, even as we're racing towards AGI. And that perhaps, right, it's hard to avoid in this hype cycle of AI agents, but perhaps we don't need the autonomous agent hammer for all of the nails. We can accomplish a lot by having more deterministic agentic workflows. And even if and when your organization deploy a more autonomous agent, its performance is directly correlated to the semantics layer, right? I like to think of the agent as like a really smart brain, right? If you throw it into a library that has all the answers to your questions, but then none of the books are labeled, it's still going to take a very long time to get to the answer. And you might not want to pay for the tokens or wait around for that answer to be achieved. And finally, so that leads to my final point, everything becomes an optimization problem in the end. And in the world of AI agents, that's a balance between cost token, compute versus the quality of the output. Yeah, so those are the dials that we're playing with. And with that, I'm done.
Hello, everyone. Welcome to the session. This is Alex. He's an FME expert and a trainer, and he'll be talking to us today about his FME AI Checker. And with that, we'll get started.
Good day, everyone. Thank you for choosing to attend my little talk. So this is about a little project that I have been working on, trying to identify errors and to annotate a workflow that you would have. So let's get started. My name is Alex. I am a happy FME expert trainer at Verimus, which is a partner of Say Software in France. So to give you a little idea of what we'll be talking about, first of all, we'll kind of dive into why I would need an AI checking tool. And then we'll see how I built this. We'll see how can I explore the structure of FMW files to do that. And then we'll see how to communicate with AI, prompts, engineering, etc. And then the overall workflow design, because this project is a FME project. We'll discuss some results, have a little discussion over those results, see how good or bad it was, and conclude on that. So why do I need a AI checking tool for FME? I'm a new hire. Let's imagine I'm a new hire. And yeah, I just got a new training from my peers, or just got on the FME Academy. And I think, well, I made something. I think my workflow is ready to be published on our production FME flow. I'm really excited about this. And this is what my workflow looks like. With a trained eye, we see that my HTTP caller here, well, has a little thing going on. We have a little error or misparametered something. Same for my coordinate system setter, and I'm missing a connection on my spatial filter. I have my little tool, which is a FME flow app. So it's written in French because we're in France, but it's a little FME flow app into which I basically upload my FMW workflow, just like that. Here, I basically choose a mode. I have 2 execution modes. We'll discuss about this later on. This is the error checking mode. And here, I have a little user parameter where I say what issue I've encountered. Here, I'm typing my workflow is not running. Things are getting executed, and I can download a copy of my original workflow right there, which is annotated and looks like that. I exactly see where I had errors in my workflow, and I know exactly why I had errors in my workflow. All issues have been detected. So for example, here, if you have issues reading, it says HTTP caller transformer is missing a target URL. So I probably forgot to put a URL in my HTTP caller. Coordinate system setter didn't have a coordinate system specified. And it's telling me that my spatial filter is missing a filter connection. So basically everything has been figured out for me and shown where it is. So that's the result. This project has been done using our traditional ChatGPT. This is not an AI that we trained. It's a project that we try to do with the least amount of resources as possible and the most accessible things that we could do to play. This tool, what can it do for me? It can allow instant verification of transformer configuration, logic and expressions in transformers according to their role, which is important here, and overall give me feedback about global workflow design. And it can also provide me instant feedback on inefficiencies and suggest potential improvements. Let's take a look at how we can approach to build something like this. Every FMW file, which is your FME workflow file, is an XML file. For those who are not really confident or with those XML, it's basically just a hierarchical tree-like organization of tagged elements. So everything is inside a tag. In an FME form workflow, we find many tags. We have a datasets tag that contains all reader-writer information. We have transformers tag that stores all my transformers parameters, and comments tag that have all my comments, etc. And so forth. We have quite a few. So here, to be able to analyze basically what I did in my workflow, I'm going to split this long XML file, which is my FMW file, so that I can harvest the transformer session, which will be sent to the AI service for review. So we basically did this. All right, so here I figured out that my FMW is an XML. I fetched the transformers tag. Let's talk to the AI. My fragments of my FME form workflow, so that transformer tag in my XML, will be sent to OpenAI ChatGPT using the connector that you know really well now, I'm sure. But as usual, when I'm doing a prompt now, I really need to frame how the answer needs to be returned, because I will be splitting that answer, so I need a consistent structure. So this is the prompt that I went for. So fragment is an attribute here. At value of fragment is an attribute that stores my transformer section. And basically, I'm telling a ChatGPT, hey, this fragment is my transformers. Review this workflow by analyzing the parameters. The error is a user parameter in which the user says what issue they encountered in their workflow. It can be null as well. You must warn about those things. I don't want to see anything else than this. So this is the main task that I'm asking the AI to do. Now there's a rule. I am manipulating this answer through attribute splitters. I do not want to have a complete different structure of answer every time. So that the rule is you need to format your response as follows. And I do not want any verbose. I need you to show me what, which basically will tell me what the issue is. I want the same for fix. And then underneath, I have identifier position. In any FME workflow, each transformer that you put in your workflow has an ID. And it's recognized like that. It has an ID and it has a position within the canvas of your FME form. So by harvesting this, I can create annotations later on and attach them to the correct transformer. And very important, last but not the least, I need to end each set of answers by this string. So this basically is a little tag for me to be able to split each set of answers so that I can harvest, well, this is the review for this transformer, that transformer, etc. At first, I tried something that makes humanly sense, like end or stop. But the AI would interpret that sometimes as a way to finish it and not provide me that string, END or STOP. So I really need to make something that does not make sense humanly so that I'm sure that every single time I'm having EOC like this. So end of comment with a pipe. So I went for this. This is what the answer looks like. So this is heavily structured. It's really easy for me to manipulate in FME. So here I sent that to the HTTP caller that we saw earlier. So it's telling me, well, that's your error. That's where you got to fix. And this is where the transformer is. And that's the ID of the transformer of the comment. So now I can use that. OK. So now we figured out that my FME is a XML file. We fetched the XML. I know how to talk to the AI about this. Let's create the overall FME project that will send my project to the AI and create a copy so that I can open it. This is a really high level of that workflow. We'll dissect that together. Basically, it's just three main sections. I manipulate my original workflow in order to harvest that XML, analyze it using the AI, and I assemble a copy of it. So let's dive in. At first, I read my FMW workflow using a text line reader because it's just an XML. So I can just allow all extensions to be read on my text line reader, and I can choose my FME workflow just as a text file. I'm splitting it to just keep the transformer section. So now here, I'm going to be creating groups of under 25 characters per feature. Why am I doing that? Because we have a basic OpenAI account. We do not want it to be expensive. It's really a little research project. We have a token limit. And in those, it's a lot of characters that I'm sending to ChatGPT. If I send the whole workflow, it's a whole long XML file. So basically, I'm creating groups of transformers, and I will batch send them using, if I'm using my computer, using workspace runners to a child project, or FME Flow job submitters, if I'm sending that on FME Flow. So here, I'm creating groups of transformers. So this is done using Python because I don't want to cut in the middle of a transformer. That would be really sad. So I basically make sure that I harvest a bunch of transformers and another bunch of transformers. So that's what's done here. We also have the execution mode selection that happens there. So do I check things? So do I check errors? Or do I want an annotation of my workflow? Two modes. Error checking modes evaluates my transformers. Annotation modes reads all the transformers I put there and tell me what they do. Each of them will have an annotation telling me what they're doing. So let's talk to AI now. So we have a little divide here because of those two modes. The upper mode is the error checking mode. So this is where I'm talking to the AI to analyze the parameters. Underneath is the annotation mode. So here I have a little interesting thing. So I realized that when I do the error checking mode, ChatGPT will return me a lot of things he may think that is an error. So for example, we don't see it as a user, but in the XML file for an attribute manager, there is a choice of coordinate system. It's in the XML. ChatGPT will tell me, hey, you didn't specify the coordinate system, but maybe that's not my point here. Maybe I really don't care about this. So I'm sending that answer back to ChatGPT again for review. And the second call is, can you please evaluate this set of warnings and only downsize to the ones that is really critical for any workflow to function or malfunction? That's what's happening here. So why is this annotation mode bypassing underneath? Well, I'm not reviewing errors. I just want to have information about everything in my workflow. So since this will be a selection of things that really matter, here I want all the information, so I'm bypassing. I don't need an additional review. I just want to fetch everything in there. All right. And the last piece of that workflow, I'm reconstructing the original FMW, which is my XML file, which will be a text line writer. I need to escape HTML because in those annotations that you put in FME, it's HTML writing in there. And yeah, some data cleanup and merging all these annotations that I created back into the original XML of my workflow and save that as a .fmw using my text line writer. So that was dense, but let's try to look at some results and let's see what we have. So here I have an attribute creator to which I say, hey, I want an attribute that's called pop density. And what did I do? Like math in there, I divide area by population. And that's wrong logic. It should be the reverse. This is exactly what it's telling me. Hey, your attribute manager has a logical error in there. It should be population divided by area, not the other way around. So this was found on my attribute manager. Next thing, JSON fragmenter. I teach beginner classes for FME. When we start the API chapter, the JSON query can be overwhelming for new users because they're not used to handling data sometimes like this. So here in my JSON fragmenter, I just put states because my JSON, the first key I have is states. I want to fetch that. So I put states, but that's not a JSON query. That's just a string here. It should have been like this. This is what allows me to fetch everything within the states tag. Well, this is what it's telling me. Your parameter is set to states like this, but it's not clear if that's the correct path in your JSON to fetch the information. So something is wrong, which is correct. This is an interesting one. I really like this one. So here, I have a geometry cursor that just resets geometry to something that you choose, and I chose a FME line. I want my feature to be a line. But after that, I'm sending it to a point on area overlayer, and it's expecting a point here, but I'm making a line. So it's telling me, hey, your geometry cursor before this transformer is set to line, but this point on area overlayer is expecting a point. So this was really an impressive result for me. For, again, general ChatGPT that you can ask, what's the recipe for tomato soup? Here, well, it just shows that it's missing a filter connection here. So yeah, that's another thing it was able to find. So that's the final product of a detection of errors mode. And so we see that only the errors are shown. Now, if I use workflow annotation mode, now I see that everything is annotated and is explaining me in human language what it does. So for example, a vertex creator creates a vertex at specified coordinates. Projector reprojects spatial data to a specified coordinate system, etc., and so forth. Okay, so let's review answers quality here. We ran FME AI Checker, so that little app, 100 times. Over 100 times, so error checking mode 57 times, notation mode 43 times. My overall answer quality over those 100 results is 6.12 out of 10. So we analyzed that answer and we graded over 10 points how good or bad it is. So 6.12 out of 10. I have a standard deviation of 3.2, which is really high for an average of 6.12. So we observed that we have really outstanding results 27 times, but really disappointing answers 28 times. So it's as impressive as it is really bad. My annotation mode still showed 80% acceptable results, and my error checking mode showed about 65% of overall acceptable results. Acceptable results meaning it's better than average. So where does it messes up? We saw that incorrect configuration of attribute transformers, poorly implemented code, miscommunicating with web services, improper transformer implementation. This is easy for general ChatGPT to see. On the other hand, special related issues, wrong transformer logic, this can be a little more delicate. Niche transformers, raster parameter, Voronoi diagrammer, etc. Those is difficult to identify because I don't think he has enough knowledge as a general AI to understand what those do. It's the same for hub transformers, hub custom transformers and connectors and stuff. So is this a new approach to workflow review? Well, it still provided 65% of the time instant feedback on my stuff and suggested potential improvement. And 80% of the time still annotated my workflow in seconds. So can I use this service that I created out of general stuff as a trustworthy review machine? And can I just skip my code review sessions now? Well, over 100 times, we encountered 15% of results is inconsistent and shows laziness. It would fail to adhere to the required answering structure, that rule that I created, that I want you to answer a certain way. It will fail to follow that. It will fail to review all transformers and how is analysis midway, like we can see here. I have an annotation here, I have an annotation here, and nothing in there. And there's no explanation. It just didn't do the job. I also, rarely, but still there, saw a few of what I would say hallucinations. I have a list concatenator, and it's telling me that the test close parameter is incorrectly set. There is no test in the list concatenator. This doesn't exist. And of course, the token limit as a really cheap project here really makes the analysis a little shorter because we only analyze the transformer stack, and we could have errors in readers, we could have errors in writers, maybe scripted parameters, and so forth. So those, as of right now, won't be reviewed by this project because we just cut only the transformer stack in my workflow. And so, yeah, as I said, this ChatGPT isn't trained on FME. It's just having whatever general data it has. So how can we improve this? Well, it would be great to remove those token limits so that I can send my whole FMW file, my whole workflow for analysis. And of course, train my own model. Training my own model will bring domain-specific expertise, increase efficiency, more customization, better accuracy. This is not anything that I'm teaching to you, I think, in this conference. I have this sentence from Professor Lai Feifei, which is really famous computer scientist. She says that accuracy in AI is not about getting the right answer. It's about understanding the confidence and the limits of that answer. And this is really resonating well in this project because, well, I'm using a general AI that people ask, how do I make tomato soup? How do I clean my cat? Well, is my attribute manager well parametered? So of course, we need to take into consideration that maybe we need to have a better train tool. Thank you very much.